Now we're going to see how we can find the minimal function if we have a function of 5 variables. So we're going to denote the variables x1 to x5, and x1 is the most significant bit when we write it on this form here. So we are given the onset of our Boolean function, and the rows in the truth table are here represented by digits from 0 to 31. Our Karnaugh maps can only have at most 2 variables in each dimension, and since we have 5 variables here, we need to solve this by looking at 3 dimensions instead of 2 as we have done previously. So what we need to do here is to use 2 separate Karnaugh maps, and then we view them as the third dimension. So we're going to view them as one map being on top of the other map. So for the first Karnaugh map, we're going to fix the variable x1 to be 0, and for the second one we're going to fix the variable x1 to be 1. So this here will correspond to the function f when x1 is a 0, and this one will correspond to the function f when x1 is a 1. Now if we compare this to how we have denoted the rows in the truth table, as before, this will be 0, 1, 2, 3, and then we have 4, 5, 6, and 7. 8, 9, 10, and 11, 12, 13, 14, and 15. So this is what we have seen before when we had 4 variables. And now since we have a 5th variable, what we get here is basically the same, but now we just have to add 16 to each of the numbers here. So here we get 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, and 31. So using this we can just fill out our Karnaugh maps. So we have 1s at 4, 5, 6, and 7, and we also have 1s at 13 and 15. Then we have 20, 21, and 23, 26 and 27, 29, 30, and 31. And then the rest of the entries will be zeros. We can fill these out as only zeros. 0 here, 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 and here. So now we have defined our Karnaugh maps, and now we want to do basically the same thing as before, but we need to remember that this is actually one Karnaugh map where one map is on the top of the other. So if we look here at our first one that we can find in our Karnaugh map, this can be covered by the prime implicant given by this box here, but it can also be covered by another prime implicant also covering 4 1s. And this is the one that consists of this box in the first dimension and then this box in our other dimension, because we have to see this second map here as being on top of the other one. And let us just for clarification make this in a different color so we can see that this covers both our Karnaugh maps that we have. So we make it like this instead. And then for the next one we have already 2 prime implicants which covers 4 1s, but if we look at the 2 Karnaugh maps that we have here, we can find an even larger one which covers 4 1s in each table, so it covers in total 8 1s here. And then for this Karnaugh map on the left hand side we cannot find any more prime implicants for any of the 1s, but if we go to the right hand side we still have a few more 1s to cover, and we can cover these 4 1s that we have on the bottom right part using this box here, which is a prime implicant. This covers all the prime implicants that you have for both our 2 Karnaugh maps here, But when you do this yourself, make sure that you do this in a structured way so you do not miss any prime implicant. It is very easy to overlook some of the boxes that you can write for the prime implicants if you do not do it in a structured way. So now we just name them as this one we call A, this one we call B, we call this one C, and finally we call this one here D. Now let us write the expressions for our implicants here. So we start with A, which covers both our Karnaugh maps. So this will not be dependent on x1. So this can be written as x2 prime x3, and then these two columns will have x4 equals 0, so it will be x4 prime here. For B, this only covers the left Karnaugh map. So in this case we will have x1 prime, because for this one x1 is a 0. And then we have this complete row here, which is x2 prime x3. Continuing, we have C, which again covers both our Karnaugh maps. So here we have x2 x5, and then finally our prime implicant D, which only covers the rightmost Karnaugh map. Here we have x1, because x1 must be a 1 here in this Karnaugh map, and then we have x2 and x4. And we can also see that all of these prime implicants are essential. So for example, A is essential because of this one here, it's the only one that covers this one. B is essential because of this one here. C is essential because of this one here, this and this. And D is also essential because it's the only box covering this, and this one here. So we can write our function f as A or B or C or D, which can be written as x2 prime, x3, x4 prime, or x1 prime, x2 prime, x3, or x2, x5, or x1, x2, x4. So this is the expression on disjunctive form for our Boolean function f.